Hello, in this video I'm going to describe how we're going to complete a HelloFresh heat and thermodynamics project. First off, a little background. If you're not already familiar with HelloFresh, it is a company that ships refrigerated, ready-to-cook meals to your home. While every company out there is clearly trying to turn a profit, one of the first things you'll notice if you receive a HelloFresh in the mail is that the internal and external packaging and components all stress the importance of conservation, being carbon neutral, and keeping those goods fresh. Now it's time to talk about your project. First off, there are many NGSS standards that are addressed with this project. First is to design, evaluate, and refine a solution for reducing the impacts of human activities on the environment and biodiversity. To evaluate a solution to a complex real-world problem based upon prioritized criteria and trade-offs that account for a range of constraints, including cost, safety, reliability, and aesthetics, as well as possible social, cultural, and environmental impacts. And to design a solution to a complex real-world problem by breaking it down into smaller, more manageable problems that can be solved through engineering. The content and language objectives is that you can design a shipping container to conserve as much heat as possible. And a language objective, you can write explanations and questions about your design when producing a scientific model. An overview, you're going to be working alone or in assigned pairs, and you're going to be applying knowledge of experimental design, engineering, heat, and energy to build a shipping container to insulate cold food. First, you're going to start with researching shipping options. Be sure to think about the following things in the planning and design of your container, which should be at least 1 cubic foot in volume, like a typical box from HelloFresh. What do actual companies do? HelloFresh, I've received dozens of different boxes in the mail from this company, and the actual components, the actual insulation, varies from time to time. So like what materials are used, how much is this going to cost to ship, how green is this choice? You can address any or all of these questions. Your container design, you're going to need to brainstorm and conduct some research before you can begin construction. So think of different factors that you can change to improve your container design. You're going to start off by creating a scientific model showing your container design. You're going to explain how your overall design will be best for shipping refrigerated goods. You're going to include all these components in a scientific model, and I'll explain this more on the next slide. And in addition, you're going to include the cost for different materials that you intend to use. So what should a scientific model contain? There are 5 different components you need. You need an explanation. The explanation can include any materials you're going to use, why, your design, how did you come to this conclusion, any companies that you've researched and what they do, just as some examples. You need a picture of what your design is going to look like. Your picture should include colors and labels. The colors can be used to just distinguish between different components. Labels, so it's clear what you're talking about. And then finally, any questions that you have. Legitimate questions you still have about your design. If your explanation is rather small, maybe you have lots of questions. If you know exactly what your plan is, maybe you have relatively few questions. Here's an example scientific model for an egg drop project. You can see in this picture that there are colors and labels. The color is not necessarily for artistic means, but just to distinguish between different parts. Labels so it's clear what different things are. There's an explanation in the bottom left corner of their design choices. And there are questions on the right-hand side. Questions that the student still has about what they intend to do. Construction is going to be optional for this. So most projects, it's all about the building, it's all about the construction. In this case, what I'm looking for your final grade is your design, is your plan, is your research. The construction, if you choose to do so, will be extra credit. And what we'll do is we'll place ice cubes in your container and see how long that it takes those ice cubes to melt. Since many of the supplies that you have available at home might be kind of limited, they're not going to be the same from person to person or household to household. And then you will, at the end, answer some conclusion questions. What are some of the trade-offs that you considered when designing your shipping container? Again, think of how green your choice is. Think of the cost of shipping. Think of the amount of time that it takes to ship the materials that you're going to be shipping. What would the total cost be to ship a package using your design? Companies get bulk discounts for things, but you can look up the cost of materials that you're going to use and you could research the cost for FedEx, UPS, USPS to ship your materials from one location to another. 3, what is one of the challenges that you encountered in your design that you didn't expect? And that could be anything you encounter from research to design. What is one thing that another group did or used that you think is a great idea? We're going to share all these ideas eventually in a discussion. So what ideas that you didn't consider did another group come up with? And then what do heat and thermodynamics have to do with this project? Just to tie in the different ways that heat's transferred, different temperature scales into this project. Now that you have all the details for this project, it's time to provide an overview or a summary of what are you going to do on day 1, day 2 of this project. Day number 1, step number 1, what you should take care of is the research for this project. Figure out what real companies do to ship refrigerated or frozen goods from one area of the United States or one area of the world to another. Step number 2, consider the pros and the cons of using different materials in terms of their cost, how green something is, even different ways to ship materials, how long it's going to take, the trade-offs along the way. Step number 3 on day 1 is you should produce a scientific model that outlines your plan, your materials, your design for this project. Day 2, what we'll take care of, the first is optional, but you can actually build this device, build this container that you could ship, and you can test it out and see how effective it is. But we've done a whole lot of building and a whole lot of construction lately, and so if you want to skip that step, it's absolutely fine. That's just extra credit. We will compare the ideas that students have from one person or one group to another to see what seems most effective. And then the last thing is you'll answer conclusion questions about heat and thermodynamics and how it applies to this project. So that's all I've got. If you have any questions, make sure to email. Thanks so much and have a great day.